Hello, people. This is the video solution for homework number 17. I'm sorry, homework number 17, and it deals with solving basic trigonometric equations and other compound ones that you can reduce it to a basic equation. Now, unfortunately, I have a cold today, so I don't know how successful I'm going to be in completing this thing. Now, notice that in number 17, it says here is a basic. This is a basic trigonometric equation, namely cosine of an angle equal to dot dot dot, or sine or tangent. And it says, okay, find six specific solutions. What I'm going to do is I'm going to find all solutions, such as what it is being asked in 25 through 34. However, once I get that, then I can find as many specific solutions, such as six ones that it's asking for. All right, so let's start with number 70. Okay, number 17. And here is how the problem is. Cosine of theta equal to minus root 3 over 2. Now, you need to be good in those standard angles, the cosine, sine, and tangent. And notice that when you look at this equation, if I don't want to use the my calculator, and I'm not supposed to, by the way, here, then because I want to find the exact solution. So we know from what we did before that theta is equal to uh, cos inverse minus root 3 over 2. Now, whenever you write cos inverse, the angle that comes out, like angle theta, is going to be between 0 and pi. Go back to your notes and find out what were the range of cos inverse, okay? So that being the case, theta is going to be pi over 2 pi over 2 pi over 3, 120 degrees. If you put this thing in your calculator, cos inverse of minus root 3 over 2, sure, you're gonna get, uh, I just want to make sure that I did this thing, cosine of, actually, this is not, this is not correct. This should be, let's clean it up. Notice that cosine of 5 pi over 6 is actually root 3 over 2. However, because the minus, we have to take 5 pi over 6. If you put this in your calculator and you said, give me the angle in degrees, what it's going to spit out is 150 degrees. And 150 degrees is actually 5 pi over 6. So what happened is the following. Look at the trig circle. Here's a trig circle. This is cosine. This is sine. And you said my cosine is minus root 3 over 2. So minus root 3 over 2 is somewhere here. This is minus root 3 over 2. And notice that the angle that you got is actually this angle. You got this angle. But there is another angle within one period which makes that thing true. And that is, I'm going to use a different color here, and that is this angle. Which means another solution, theta, in that same period is, if you look at that, well, let's see now, this is 150, so this is going to be 210, which means theta equal to, let's say 2 pi minus 5 pi over 6, and this is 7 pi over 6. So look at what happened. I was given this equation. Cosine of theta equal to minus root 3 over 2. I found two solutions in one period of the function. And I want to remind you that the period of the function is 2 pi. Therefore, if I want all solutions, for all solutions, what you say is theta equal to whatever you got. It was 5 pi over 6, correct? 5 pi over 6 plus or plus 2 pi k. And theta equal to this fellow, 7 pi over 6 plus 2 pi k, where k is any positive or negative integer. K equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. So this is all the solutions. Excuse me. This is all the solution. And if you want the first six solutions, well, you just set, for example, two of them you already know, 5 pi over 6 and 7 pi over 6. We already got these. Then let's say you add, you set k equal to 1, so you get 2 pi uh, plus 5 pi over 6. Let me write it in the same order. So this is two of them you can already see, and then 5 pi over 6 plus 2 pi, which incidentally it's 17 pi over 6, and 7 pi over 6 plus 2 pi, which is 19 pi over 6. And then, for example, this I got it by setting a k equal to 1. I got these by setting k equal to 1. I set 1 by k equal to minus 1. So you have theta equal to 5 pi over 6 minus 2 pi. And this is minus 7 pi over 6. And theta equal to 7 pi over 6 minus 2 pi. And this is minus, what is that? Minus 12, minus, let's make sure we get this thing right. Yeah, so minus 5 pi over 6. Okay, look, I found 6 solutions. I found all solutions. If it says all solution, you need to have a k in there with different values of the integer, and specific solutions can be obtained from setting k equal to different values. Okay, so let's go to the next problem. Okay, next problem is number 18. Cosine of theta equal to 1/2. Immediately, I recognize that theta equal to pi over 3. Okay. In other words, if you put this is 60 degrees, right? If you put cosine of 60 degrees is 1/2. Now, another way of saying the same thing is that theta is equal to cos inverse of 1/2. The only problem is that when you say this, then the angle that it spits out, it's going to be between 0 and pi. Go back to your notes from cos inverse function. Okay, so here's what happened. This is the situation. I found this is the value of 1/2, cosine being 1/2. I found one angle right there, right there. Okay, and this one was your pi over 3. But in one period, there is another angle, which is over here, which gives you, oh, I'm sorry, this is the wrong one. But there's another angle down there, right there, within one period. In other words, this angle, which whose cosine is also 1/2. So theta equal to pi over 3 is fine. There's nothing wrong with it. But theta equal to 5 pi over 3 is also a solution in one period. Remember, one period of cosine is 0 to 2 pi. So once you get this, then you get the general solution. All solutions is theta equal to pi over 3 plus 2k pi or 2 pi k and theta equal to 5 pi over 3 plus 2 pi k, where k is equal to 0, plus or minus 1, plus or minus 2, basically all positive and negative integers. This is all solution. 6 solutions. We could just use different values of k. For example, let me say k equal to 0 here. Obviously, theta is going to be pi over 3, and theta is going to be 5 pi over 3, the original ones that I've got. K equal to 1, so it's going to be pi over 3 plus 2 pi, which is 7 pi over 3, and pi over 3, 5 pi over 3 plus 2 pi, which is 6, 11 pi over 3. K equal to minus 1, you get pi over 3 minus 2 pi, and this is minus 5 pi over 3. And 5 pi over 3 minus 2 pi, and this is negative pi over 3. And here we found 6 specific solutions. So if you can find this, getting the 6 solution or 7 or 8 solution, whatever is nothing. So what I'm going to do is for this remaining problems in this block, I'm just going to find the general solution, okay? Because there is no intellectual content when you're supposed to set value of k to different numbers and work it out. That's up to you. It's good. You can always check it, okay? You can always check it. Let's do the next one. Number 19. Sine of theta equal to root 2 over 2. So theta equal to sine inverse root 2 over 2, and we know what this thing is, pi over 4. But there are other solutions in the one period that I have to get it myself. If I put this thing in my calculator, it will only spit out this particular angle. It will not spit out the other one. So let's plot it and see what happens. This was cosine. This is sine. Root 2 over 2 is somewhere here. The angle that we got is this one. We got that, pi over 4. But there's another one on this side, which is 3 pi over 4. This angle, 3 pi over 4, which is also whose sine is 1, root 2 over 2, okay? So we found two things. One equal to pi over 4, and the other one is equal to 3 pi over 4. If you simply rely on your calculator, you can get that. You will not be able to get the other one. So general solution or all solutions, just write the ones that you found in one period. Theta equal to pi over 4 plus 2 pi k, and theta equal to 3 pi over 4 plus 2 pi k, where k is equal to 0, plus or minus 1, plus or minus 2, etc. And for the 6 solutions, all you do, if you want 6 solutions, just pick 6 of these k values. For example, k equal to 0, k equal to 1, k equal to minus 1. That's entirely up to you. I'm not suggesting that you only do you do these specific values of. You can take any case that you want. Give me six answers. Okay? So that's this. Let's do the other one. Number 20. So this is number 20. We have sine of theta equal to minus root 3 over 2. Okay. So if you relied on your calculator, you don't have to. You do this. Okay. What the calculator will spit out, calculator will spit out theta equal to minus pi over 3. Because remember, as soon as you try sine inverse, the angle that comes out is between minus pi over 2 and pi over 2. Go check your notes from sine inverse function. Okay. Now, so here's the situation. Minus root 3 over 2 is some number here. Okay. And the angle that we got was this one, minus pi over 3. But then there's another one on that side within one period up to this location, this one, which is minus 2 pi over 3. So we found two values in one period. One is minus pi over 3, and the other one is minus 2 pi over oh yeah uh, minus 2 pi over 3. Correct, that's correct. The calculator only spits out the one that's between minus pi over 2 and pi over 2. That's this. The other one you have to identify it yourself from for example your graph, etc. So all solution is going to be theta equal to minus pi over 3 plus 2 pi k, and theta equal to minus 2 pi over 3 plus 2 pi k, where k is equal to 0, plus minus 1, plus minus 2, etc. To find 6 solutions, as you are instructed, use 6 values or 3 values of k. For example, k equal to 0, k equal to plus or minus 1. Yeah, that'll do it. So I said I was not going to do that, but what the heck, let's try it. K equal to 0. Of course, you're going to get your original angles, minus pi over 3, minus 2 pi over 3. K equal to 1. You get minus pi over 3 plus 2 pi, minus 2 pi over 3 plus 2 pi. And k equal to minus 1, minus pi over 3 minus 2 pi, and minus 2 pi over 3 minus 2 pi. Okay, so let me stop the video segment here. This is already about 20 minutes long, so let me stop it, and then 21, 22, 23, and 24 we're going to do it in different segments.